On the 18th of October, behind the sun's glare, three entities materialized alongside the interstellar object 3E Atlas, appearances that defied all expectation. The sun, which had maintained an unusual calm for several weeks, suddenly roared to life with a violent outburst. It didn't erupt once nor twice, but on three separate occasions, each surge coinciding with the passage of these three intruding objects. Every moment was captured by optical devices. The trajectory of these objects was impossibly precise, unnaturally controlled, and far too perfect to be attributed to chance. Yet, an eerie silence followed. No official statement was issued, no prominent headline graced the news. This is characteristic of a deliberate suppression of information, or perhaps they are hoping for widespread ignorance. Well, their hopes are misplaced. Tonight, we delve into restricted data, and what we uncover at the conclusion will offer a glimpse into the most perilous secret currently facing the field of astronomy. If these enigmas continue to disrupt your sleep as they do mine, be sure to click the like button and subscribe to ensure you're present for every unfolding revelation in real time. In the comments section, let me know your location, the current time where you are, and answer me directly. Do you believe we are being presented with the complete truth regarding these mysteries? And if you wish to extend this dialogue further, please share this video across X, Facebook, Reddit, or even within your group chats. This community thrives because of your engagement, and your unwavering support empowers us to continue investigating threads that the world would prefer to overlook. Part 1. The Inexplicable Recording. Envision yourself observing a live broadcast on an unremarkable Tuesday afternoon. The sun appears on your screen, serene and distant, a golden orb suspended in the digital void. But then a subtle alteration occurs. Three dark, unidentified objects, moving with deliberate precision, glide across the frame in swift succession. Each one passes, and moments after its departure, the sun ignites, not once, not twice, but three times. The sun had been uncharacteristically quiescent for weeks. However, the instant these objects traversed its vicinity, it awakened with startling intensity, as though jolted by an electrical surge. This is not conjecture. This is precisely what amateur astronomer Tiago, known online as Dobsonian Power, meticulously recorded and shared with the global audience this week. His findings have profoundly challenged our established assumptions about the possibilities within our solar system. The imagery originates from LASCO, the large-angle and spectrometric coronagraph instruments aboard the Solar and Heliospheric Observatory, or SOHO, a satellite that has continuously monitored the sun for 3 decades. These are not fuzzy smartphone captures or subjective interpretations. These are official data feeds, identical to the images that NASA scientists scrutinize daily. What Tiago documented was a phenomenon that, according to our current understanding of orbital dynamics and solar physics, should not exist. The three objects he captured were in alignment. They moved in a coordinated formation. They were not random celestial debris hurtling towards our star. Their trajectories implied intent. Their timing suggested prearrangement. Upon publishing his findings, Tiago referred to them as companions, or dark matter accompanying 3 Atlas, the interstellar object that entered our solar system from beyond its boundaries in late 2024. The online astronomical community was immediately abuzz. This is the juncture where the narrative becomes uncomfortable for mainstream science. The statistical likelihood of 3 independent objects triggering 3 solar events in sequence is so infinitesimally small that presenting it through conventional probability calculations would elicit derision. We are not discussing improbability. We are discussing a degree of improbability that compels one to pause and consider if something more profound is unfolding beneath the surface. 3 objects, 3 explosions. The pattern is too immaculate. The timing is too exact. The coincidence is too perfect. In any discipline involving data analysis, one learns that patterns of this nature do not arise by chance. They manifest because a directive force is at play. Nevertheless, silence ensued. No press conferences from NASA, no statements from any major scientific body, no official acknowledgement from any prominent space agency or research institution. The very entities tasked with comprehending our solar system offered no response. In an era where every discovery is amplified and celebrated, where the detection of distant exoplanets or gravitational waves generates immediate global attention, the images of these three objects passed through official channels and encountered what can only be described as institutional radio silence. This void of commentary becomes its own declaration, raising its own questions. Why would the organizations that observe every solar event, employing thousands of scientists, remain utterly mute regarding an occurrence that fundamentally contradicts our established understanding of what is possible in near-solar space? Independent observers were also watching. Sky watchers Onyx, identified as Night Monkey, and Tobazil, both seasoned in identifying celestial phenomena, reported observing swift-moving points of light near Gemini and across various sky surveys. Their observations corroborated Tiago's timeline. Multiple independent sources, utilizing different equipment and from distinct vantage points, all reported the same phenomenon within the same temporal window. When a single observer reports an anomaly, it's noted as a curiosity. When 5 observers independently report the same event, it constitutes corroboration. When institutions disregard corroboration, one must question their motivations. The reasons for this silence are not difficult to surmise. The discovery of artificial objects in near-solar space would necessitate a complete re-evaluation of our understanding of humanity's position in the cosmos. It would instantly transform from a scientific curiosity into a global geopolitical crisis. It would spawn legal, military, and existential quandaries that no government or scientific body is adequately prepared to address. There is a perceived safety in silence, a protection found in feigning ignorance. However, silence also creates a void, and a void inevitably invites speculation, conspiracy theories, and the subsequent deluge of misinformation. A more astute and ethical approach would involve openly acknowledging and investigating what was observed. Instead, we are left with a question that the official scientific community steadfastly refuses to pose. Could this represent the first publicly documented kinetic intervention in solar physics? Could we be witnessing in real time humanity's inaugural encounter with non-human intelligence? These are the questions that keep us vigilant, and they originate with 3 objects and 3 solar outbursts that no authority figure is willing to discuss. Part 2. Pattern recognition or deliberate obfuscation. Probability serves as a stark indicator. When applied to the events surrounding 3E Atlas, a clear pattern emerges. If 3 distinct objects, each entering near solar space, and each independently inducing solar eruptions, were all part of a purely random sequence of events, the odds would be comparable to shuffling a standard deck of cards and drawing the ace of spades 500 consecutive times. While not strictly impossible, it is so statistically improbable that proposing chance as the cause would signify either profound ignorance or outright denial. The human brain is inherently wired to recognize patterns. This is a fundamental aspect of our species' survival. A recurring pattern, be it indicative of a predator or prey, immediately captures our attention. A repeating sequence compels our investigation. 3 explosions following 3 passages are not mere background noise. They constitute a clear signal. This is where institutional science often retreats into a defensive posture. Scientists will correctly assert that correlation does not imply causation, that extraordinary claims demand extraordinary evidence, and that maintaining healthy skepticism is paramount. All these principles are valid and important. However, Healthy skepticism can devolve into a pathological state when it insists on disregarding evidence that challenges established models. When we dismiss data solely because it conflicts with our prior knowledge, we are not acting scientifically. We are behaving dogmatically. We are prioritizing the preservation of our theories over the pursuit of truth. Sabine Hosenfelder, a physicist with decades of esteemed experience, has specifically cautioned against this very tendency. She has publicly stated that rejecting the possibility of an artificial origin without rigorous investigation would constitute the single greatest error our civilization could commit. Not merely an error, but the error of paramount significance. The sequence of events is critical in this context, therefore let us meticulously review it. In the weeks preceding Tiago's observations, the Sun exhibited unusual quietude. Solar activity was subdued, as if the star itself were dormant. Subsequently, 3 Atlas approached, accompanied by these 3 associated objects. The moment they neared the solar surface, the star became active. The eruptions occurred in rapid succession, resembling a cascade of responses, as though the Sun were reacting to something, defending itself, or perhaps being deliberately activated by an external influence. Historical precedents offer valuable insights. When military forces first encountered the phenomenon of unidentified aerial phenomena in the 1940s and 50s, they did not immediately declassify all information. Instead, they classified it, compartmentalized it, and maintained institutional secrecy while conducting private investigations. We now understand that government agencies and military branches continuously tracked anomalous objects and events, divulging essentially nothing to the public. This secrecy persisted for 70 years. Why should the present situation be any different? Independent confirmations have continued to emerge. Night Monkey documented rapid moving signatures across numerous all-sky surveys. Tobazel tracked objects that exhibited motion inconsistent with standard cometary behavior or orbital debris patterns. Other amateur astronomers utilizing publicly accessible data from SOHO and other solar observation platforms have identified further anomalies that the mainstream astronomical community has not addressed. This is not a case of a single observer making unsubstantiated claims. It represents a growing volume of independent documentation pointing towards something tangible, something measurable, something that is present in our data, yet has not been integrated into our official narrative concerning events in near-solar space. The more closely we examine the facts, the more difficult it becomes to rationalize the institutional silence. However, the counterargument merits consideration. Space agencies often defer public statements until verification is achieved. They face genuine pressure to ensure that anomalies are authentic before disseminating them globally. The risk of raising a false alarm, of announcing a discovery that subsequently proves to be an instrumental artifact or a misinterpretation of data, is both real and significant. Scientific credibility is built gradually and lost quickly. Rushing to conclusions, even when confronted with compelling patterns, can undermine the authority of institutions that we rely on for critical information about our world and our solar system. This represents the fundamental tension at the heart of this matter. On one hand, we have institutional caution and adherence to the scientific method. On the other hand, we have the principles of transparency and public access to information concerning events that may have profound implications. Both values are important. Both give rise to legitimate demands. Neither can be fully satisfied without compromising the other. However, there is something we must not do, something we appear to be doing regardless. We cannot simply feign ignorance of these anomalies. We cannot dismiss independent observations simply because they make us uneasy. We cannot maintain silence while evidence accumulates, because prolonged silence transforms into complicity. It becomes a deliberate choice. It becomes institutional corruption disguised as prudence. The pattern is discernible. Three objects, three explosions, three independent observers documenting the same phenomenon within the same temporal framework. The evidence is not ambiguous. It is not subtle. It is not concealed within noise or distortion. It is plainly visible within our own data, awaiting acknowledgement from someone in a position of authority. And as we transition from this discussion of timing and correlation to the actual nature of the light itself, the mystery deepens into something far more perplexing. We must examine the concept of polarization and what it reveals about the composition and origin of 3E Atlas itself. Part 3. The Polarization Paradox. Light propagates as a wave, and like any wave, it oscillates. Under normal circumstances, this oscillation occurs in all directions, perpendicular to the direction of travel, akin to dropping a stone into still water, creating ripples in every direction. However, when light interacts with dust, ice crystals, or complex surfaces, a remarkable phenomenon occurs. The wave's oscillation becomes organized. It begins to oscillate preferentially in one direction or a few. This is what we term polarization, and it is extraordinarily sensitive to the physical characteristics of whatever the light has reflected off or traversed. For decades, scientists have employed polarization analysis to comprehend comets. They understand the expected patterns of polarization from specific types of dust particles. They know how ice grains polarize light differently from silicate minerals. They have compiled a catalog of typical responses, a baseline indicating how ordinary comets behave when sunlight passes through their dusty envelopes and reflects back towards Earth. 3E Atlas deviates from this baseline so drastically that the researchers who analyzed it were compelled to publish their findings under headlines that conveyed significant uncertainty and concern. A paper by Gray and colleagues documents extreme negative polarization in 3I Atlas, reaching values of minus 2.7% on curves where most comets fall between 0 and 2%. This is not a minor deviation. It falls outside the realm of normal variation. It is a pattern so unusual that existing models of dust and ice behavior struggle to provide an explanation. The polarization inversion angle is incorrect. The phase curve does not align with our expectations. The entire optical signature points to something that should not be present. If 3E Atlas is indeed a typical comet composed of ordinary ice and dust, imagine attempting to identify a human based on their fingerprint, only to find that the fingerprint does not match any database or any known type. The ridges flow in the wrong directions. The patterns do not conform to human anatomy. You would immediately suspect either that the fingerprint is counterfeit, deliberately fabricated, or that you are dealing with an individual whose biology fundamentally differs from the human norm. This is precisely what the polarization data is indicating. Either 3E Atlas possesses a surface composed of materials not commonly observed in our solar system, or its structure and texture are unlike anything we have previously catalogued. The natural progression is speculation. If not ordinary dust, then what? Exotic ices, engineered materials, surfaces designed with specific reflective properties. The mainstream response has been to propose what researchers term a porous dust grain comet model. This hypothesis suggests that 3E Atlas is composed almost entirely of solid material with minimal gaseous components, and that the dust particles themselves are larger and denser than typical comet dust. This would suppress the expected spectral signatures we normally associate with comets, while potentially accounting for some of the polarization anomalies through the sheer size and density of the particles rather than their chemical composition. This is a plausible hypothesis. It is scientifically sound. Crucially, it is also a hypothesis that conveniently avoids challenging our existing cosmological framework. It keeps 3E Atlas firmly categorized as an unusual, yet ultimately natural phenomenon. Avi Loeb, the astrophysicist who has been most amenable to considering artificial origins, assigns a probability of roughly 4 out of 10 to this natural explanation. This implies he assigns a likelihood of 6 out of 10 or higher to the alternative, something more exotic, something more deliberate. When you hear these figures, you should pause. A scientist of Loeb's standing stating that non-natural origins are more probable than natural ones is not equivalent to professing belief in extraterrestrials. It does not signify certainty, but rather indicates that the anomalies are so severe, so contrary to expectations, that the conventional explanation is actually the minority viewpoint among experts willing to engage honestly with the data. This pattern repeats across every level of analysis. The data points elsewhere, the models strain to accommodate it. The institutions remain silent, and all the while, light bends in ways we do not fully comprehend, revealing a surface or structure that defies our classifications. What polarization demonstrates is a physical characteristic of 3 Atlas that contradicts our assumptions. However, the truly damning evidence, the data that causes genuine discomfort among scientists, lies not in how light bends around this object, but in the elements that compose it. We must examine its spectrum, the chemical fingerprints that 3 Atlas is broadcasting into space. Part 4. The chemistry of the outlier. Spectroscopy is, in essence, cosmic forensics. When light passes through or reflects off matter, each chemical element leaves a unique signature, much like a fingerprint imprinted on the spectrum. Nickel produces a distinct line, iron another, and cyanide yet another. Scientists have catalogued these signatures for every element. By examining a spectrum, they can precisely identify the constituents present, their quantities, and their distribution. When the KEK Observatory, one of the world's most powerful telescopes, focused on 3 Atlas and captured its spectrum, something unprecedented appeared in the data. Nickel emission lines were detected. This is not inherently surprising, as nickel is present in comets. However, this is where the situation becomes highly intriguing. The iron lines were conspicuously absent, or rather, they were suppressed to an unusual degree. The ratio of nickel to iron in 3 Atlas is orders of magnitude higher than in any known comet. This is not merely unusual, it is fundamentally contradictory to everything we understand about the formation of objects within our solar system. The implications become even sharper when considering the cyanide ratios. Cyanide emission is a standard characteristic of comets, consistently observed across different objects. But in 3E Atlas, the nickel to cyanide ratio is immense. It is so extreme that proposing it as a natural occurrence without further explanation would result in immediate dismissal by peer review. Yet the data exists. The KEK Observatory collected it. Researchers have published it, and the mainstream astronomical community has largely disregarded it or explained it away using the porous dust grain model. However, this is where industrial chemistry enters the discussion, and the situation becomes genuinely unsettling. Nickel carbonyl is a compound with precisely one primary terrestrial application. It is utilized in industrial processes, specifically in metallurgical cycles, for the extraction and purification of nickel on an industrial scale. This compound forms when nickel is exposed to carbon monoxide under specific conditions. It is not commonly found in nature, it is engineered and manufactured. And when one observes high concentrations of nickel detached from its typical iron counterparts, when ratios contradict natural formation processes, when combinations point towards industrial metallurgy, one is compelled to at least consider the question, could something be deliberately separating these elements? The critic's response is immediate and logical. Natural nickel carbonyl pathways do exist in the interstellar medium. Carbon monoxide is present, as is nickel. Under the right conditions, the correct temperatures and pressures, naturally occurring chemical processes could produce these compounds. This does not necessitate technology or intelligence. It requires only chemistry and time. Avi Loeb himself acknowledges this, ranking the probability of an artificial origin at 4 out of 10, suggesting that natural pathways remain plausible explanations. This is important. This is where we must exercise rigor. We cannot observe a chemical anomaly and immediately leap to the conclusion of extraterrestrial involvement. That is not how science operates. This is how the tendency to confirm existing beliefs operates. We must entertain multiple potential explanations concurrently. While natural geological processes could account for the nickel concentrations, so could deliberate separation and refinement of materials. Both explanations remain viable, and both are supported by the available information. The core issue isn't about one being correct and the other incorrect. Instead, the question is which explanation is more likely, and what further evidence we would need to favor one perspective over the other. This is precisely where the lack of official communication becomes particularly vexing, as the logical next step in the inquiry is evident. We require additional spectroscopic measurements. We need improved resolution. Our understanding must extend beyond simply identifying the elements present. We need to ascertain their distribution within 3i Atlas and the physical arrangements they form. We must scrutinize isotopic ratios, which can reveal whether these elements originated from the interstellar medium or from environments altered by stellar activity. A comparative analysis with every other interstellar object ever observed is necessary to determine if these ratios are found elsewhere or if 3i Atlas stands alone. These are all reasonable avenues of investigation that any well-funded research team should be pursuing right now. Yet, minimal resources are being allocated to them. Few research papers are being published. Discussions are scarce at major astronomical gatherings. It's as if the scientific community has collectively deemed the question unworthy of exploration. And when the scientific community collectively arrives at such a decision, one is compelled to question what is being protected. The chemical composition strongly suggests something artificial, or, at the very least, something fundamentally unusual. However, chemistry alone does not definitively resolve the matter. We must examine the physical structure of 3i Atlas itself, scrutinizing the raw images captured of its core. Because what we observe there unlocks an entirely new spectrum of possibilities and conjectures. Part 5. The Stingray and the Pyramid. Raw imagery from the Gemini Observatory presents a narrative that extends beyond spectroscopy and polarization, venturing into territory that profoundly unsettles skeptics. The nucleus of 3i Atlas, when examined in the highest available resolution images, does not resemble the irregularly shaped, potato-like form typical of most comets. Instead, observers have described it as resembling a stingray configuration, exhibiting hints of internal structure and geometric patterns that depart from randomness. Some viewers, leaning heavily into speculation, have identified formations they interpret as stepped pyramids or ziggurats. Now, before we proceed, let us be absolutely clear about what we are observing. Images from telescopes are susceptible to pixelation. They are also subject to distortion from atmospheric turbulence. They can contain artifacts introduced during the imaging process. The human brain is a remarkable pattern recognition system honed by hundreds of thousands of years of evolution to perceive intent and design even in their absence. We discern faces in clouds. We perceive conspiracies within statistical anomalies. We find meaning in random occurrences. This is not inherently a flaw, but rather a feature of our survival mechanisms. However, it also serves as a source of significant error when applied to astronomical data. And yet, despite these caveats, the question of morphology holds importance. A perfectly spherical asteroid would indicate something unusual. An asteroid shaped like a perfect cube would signify something even more remarkable. Shape carries information. Shape can illuminate the formation process. Shape can reveal deliberate design, if such design exists. The debate surrounding the shape of 3i Atlas is not merely theoretical, it is tangible. Multiple observers, utilizing different telescopes at various times, have reported recurring geometric elements within the images. These are not isolated reports from fringe individuals or conspiracy theorists. These are independent observations from serious amateur and professional astronomers who are willing to risk their reputations on what they believe they perceive. The question then becomes not whether these observers are fabricating their accounts or experiencing hallucinations, but rather whether they are interpreting ambiguous data through a framework of expectation, driven by a desire to find anomalies. The broader context becomes relevant here. In early 2025, reports emerged of a high-level United States military meeting held at Quantico involving generals and personnel from the Naval Radio Telescope facility. The official account, to the extent one exists, suggests routine briefings concerning space weather and solar threats. However, the timing is suspicious. The meeting occurred immediately following the most intensive observation period of 3i Atlas. The attendees included radio telescope operators who would have access to non-optical data regarding the object, data unavailable to civilian astronomers. The presence of high-ranking military personnel implies either an unusual level of concern or an unusual level of awareness. None of this constitutes proof of anything. None of it confirms that the objects are artificial, but it also cannot be dismissed as mere coincidence. It forms part of a larger pattern. It is another thread in the fabric that suggests institutions are treating this phenomenon with greater seriousness than their public statements would indicate. The significance of shapes warrants further consideration. In the natural world, most objects are formed through random processes. Gravity draws material together from all directions, resulting in roughly spherical bodies. Solar wind shapes tails. Outgassing produces jets. These processes generate complex shapes, but they fundamentally arise from symmetrical forces. Engineered objects, those deliberately constructed, tend to exhibit different characteristics. They display angles. They reveal repeating geometries. They show configurations optimized for specific functions. They demonstrate design. When observers report stingray shapes and pyramid formations in images of 3i Atlas, they are posing the question of whether this object exhibits the characteristics of an engineered structure or a naturally occurring celestial body. The data is too pixelated and noisy to provide certainty. However, the patterns reported are too consistent across multiple observers to be dismissed as mere hallucination. We are entering a realm where truth necessitates superior data, higher resolution imagery, and more meticulous observation. And as we transition from what we can directly see to what the object might actually be doing, we must confront the possibility that 3i Atlas is not traveling in solitude, but rather accompanied by other entities moving with it for a specific purpose. Part 6: Guardians or Assassins. The three objects that Tiago documented preceding the solar eruptions invite a question that borders on science fiction, until one recalls that these objects are real, recorded in official data, and contradict every model we possess for phenomena occurring in near-solar space. If these objects are deliberately traveling with 3i Atlas, if they are somehow connected to it or controlling it, then what are they doing? What is their objective? Tiago himself has posited that they might be companions, fulfilling some role in relation to the primary body. But what role? The most straightforward interpretation is protection. Perhaps these are guardian objects positioned to defend 3i Atlas from something, to shield it from some inherent danger or threat during its passage through the inner solar system. The analogy of an escort naturally emerges. Military convoys deploy protective units around valuable cargo. They position defensive assets to establish a perimeter. They maintain vigilance against external threats. If something similar is occurring here, then 3i Atlas is valuable cargo, important enough to warrant safeguarding. important enough that whatever intelligence dispatched it is willing to deploy multiple additional objects to ensure its security. However, this is merely one interpretation. The inverse interpretation is equally plausible. What if these companion objects are not guardians but attackers? What if they are positioned not to protect, but to destabilize? What if they are actively working against 3i Atlas, disabling it or manipulating it as it traverses our solar system? In this scenario, the solar eruptions become a weapon. The companions would be utilizing the sun's own magnetic field and energy against their target, triggering coronal mass ejections and directing them with precision. It is a startling image, but no more startling than the concept of protective escorts. Both are speculations. Both are based on limited evidence. Both raise the same question. Are we witnessing a cosmic convoy or a cosmic conflict? Are we observing the initial maneuvers of a celestial dogfight that has spilled into our solar system, with the sun itself serving as the arena and 3i Atlas as either the prize or the target? The hypothesis of solar eruption triggering is testable if we consider carefully how it might operate. If the companion objects are actively initiating eruptions, we would anticipate observing recurring patterns. We would expect to see an intensification of the correlation as the objects approach and pass the sun. We would anticipate timing that is too precise to be coincidental, exhibiting evidence of deliberate targeting. We would expect to find asymmetries in the eruptions, perhaps preferentially in regions of the solar surface where the companion objects traverse. Thiago has documented aspects of this. The triple cannibal coronal mass ejection, forecasted for late January 2025, demonstrated precisely the kind of temporal correlation expected if external objects were triggering the eruptions. However, 3 data points do not establish a conclusive pattern. We require more observations. We need time to observe 3i Atlas's behavior as it continues its trajectory toward perihelion, its closest approach to the sun. The mechanism by which such triggering might occur warrants consideration, even if speculatively. Solar magnetic reconnection is an active process. The sun's magnetic field is continuously reconfiguring itself. Tensions build, energy accumulates, and release events are inevitable. But the timing and location of those releases are dictated by complex dynamics that we do not fully comprehend. Now, imagine an external object, something possessing an unusual electrical charge or an unusual composition, approaching the solar surface. Its presence within the sun's magnetosphere could generate perturbations. It could locally alter the field's topology. It could provide the final impetus to convert potential energy into kinetic energy, unleashing an eruption that was already destined to occur, but whose precise timing and location would have differed without the external disturbance. This is not sorcery. This is not technology beyond our grasp. This is simply the application of physics. But it necessitates knowledge of solar dynamics, precision navigation, and the technological capacity to approach the sun itself without being annihilated. Any civilization capable of this would be centuries ahead of us. The skeptical viewpoint highlights the energy budget challenges. To reliably trigger solar eruptions with anything less than a major celestial body, one would need to exert immense energy. This would require directed energy beams of staggering power or gravitational manipulation exceeding our theoretical models. It would necessitate technology so advanced that the concept of deploying it to trigger eruptions appears almost gratuitous, akin to using a thermonuclear device to light a candle. And yet, this is speculation built upon speculation. We do not possess definitive evidence that solar eruptions are being deliberately triggered. We have correlations. We have temporal patterns. We have objects present at the moments eruptions occur. This is not proof. But it is precisely the kind of evidence that demands investigation rather than institutional silence. As the questions surrounding the motivation and mechanism of 3I Atlas persist, another pattern begins to emerge, suggesting that this comet is not unique. Other green comets are currently visible in our skies, and they too are exhibiting unusual behavior. Part 7. The Silence of the Green Comets. In the month since 3I Atlas arrived and began displaying its array of anomalies, other comets have graced our skies. These are not random visitors. They are sufficiently close to be visible to the naked eye and to observers using binoculars. They emit the characteristic green luminescence caused by diatomic carbon molecules within their comas, the illuminated cloud of gas surrounding the nucleus. Comet C 2025 A6. Lemon arrived from the outer solar system. Comet C 2025 R2. Swan commenced its approach. Comet C 2025 K1 Atlas, sharing a name with the automated telescope system, also joined the celestial gathering. These are the overlooked counterparts to 3I Atlas, attracting minimal attention despite their proximity to Earth and their visibility to casual stargazers. Coverage in astronomical media has been sparse. Discussions within mainstream science have been virtually non-existent. And when one compares the reporting on these comets to the coverage of 3I Atlas, an interesting pattern emerges. The focus narrows. Resources are concentrated. Attention converges on the most anomalous object, leaving the others in obscurity. This might be a perfectly natural form of scientific prioritization. 3I Atlas is genuinely the most anomalous, thus naturally commanding the most attention. Scientists have limited time, limited funding, and limited resources. They must prioritize. It is logical to study the most compelling case. However, it is the silence surrounding the other green comets that is particularly noteworthy. Some of these are exhibiting peculiar behaviors, some are displaying unexpected emission lines, some are demonstrating anomalous variations in brightness, some are presenting tail orientations that do not align with models of solar wind pressure. None of this is definitively anomalous. None of it constitutes unambiguous evidence of a non-natural origin. But taken collectively, across multiple objects arriving simultaneously from space, the pattern suggests something worthy of investigation. Are these comets simply naturally more exotic than usual? Are we witnessing a rare assembly of unusual but natural objects? Or are they decoys? Are they accompanying probes? Are they part of a fleet following a deliberate itinerary? The question of institutional suppression versus selective scientific focus becomes relevant. In any field, certain topics attract funding and attention, while others languish. This is partly meritocratic, with the most intriguing questions being investigated. But it is also partly political. Questions that challenge established paradigms, that make us uncomfortable, that have implications for our understanding of the world, sometimes fail to receive the attention they merit. Instead, they encounter institutional silence. Institutions develop unofficial policies regarding which questions are permissible and which are not, which researchers can pursue topics without jeopardizing their careers, and which findings will be published and celebrated versus which will be filtered out. This is not a conspiracy theory, it is how institutions function. They possess immune systems with antibodies that neutralize foreign elements threatening their core assumptions. When data emerges that contradicts those assumptions, the immune response is triggered. The comparative analysis we need to undertake is straightforward. We must examine whether any of the other green comets exhibit the extreme negative polarization observed in 3I Atlas. We need to look for anomalous chemical ratios in their spectra. We need to assess their morphology against our models of natural comet shapes. We need to search for companion objects in high-resolution imagery. We need to correlate their approaches with solar activity. If we discover that multiple comets display the same set of anomalies, then we have moved beyond a unique mystery to a discernible pattern. and patterns indicate causes. Causes demand investigation. If we find nothing unusual in the other comets, then 3i Atlas becomes even more remarkable, even more difficult to explain through natural processes alone. In either scenario, the investigation should proceed. In either scenario, the silence surrounding these objects should cease. But it has not. And the longer this silence persists, the more we are compelled to wonder if something else is occurring beneath the surface, something coordinated, something that spans across all these comets simultaneously and suggests a single organizing principle. Perhaps they are linked by a broader cosmic design. Perhaps they are not random visitors at all. Part 8. The Solar Trigger Hypothesis. The Sun is not a quiescent sphere. It is a churning dynamic engine of nuclear fusion, encased in a magnetic field of astonishing complexity. Coronal mass ejections are violent events where the Sun's magnetic field undergoes catastrophic reconfiguration, ejecting billions of tons of plasma into space. The mechanism is understood in general terms but remains mysterious in its specifics. We know that magnetic reconnection, the rapid rearrangement of field lines, causes these explosions. We know that tension builds within the magnetic field and releases in sudden cascades. We know that the timescale can range from hours to seconds. However, we do not fully understand what triggers a specific eruption at a precise moment. We cannot predict them with accuracy. We cannot control them, or at least we cannot. But something else might possess that capability. The empirical possibility is straightforward. As 3i Atlas and its companions approached the Sun, solar eruptions increased in frequency and intensity. The correlation is evident in the data. The question is whether it is causal. Causation requires more than mere correlation. It demands a mechanism. It necessitates understanding how A leads to B. In this instance, how could external objects approaching the Sun trigger eruptions? One potential mechanism is electrostatic induction. Every object in space possesses some electrical charge, an accumulation of electrons or a deficit of electrons relative to a neutral state. When a charged object enters the Sun's magnetosphere, its electrical field interacts with the solar field. This could create localized disturbances, areas where the field's topology shifts. These disturbances could propagate outward, interact with existing tensions within the field, and provide the final trigger that converts potential energy into kinetic energy, releasing an eruption. Another possibility involves gravitational disturbance. While the gravitational influence of small objects is typically negligible, it is not non-existent. A dense, compact object approaching the Sun could generate gravitational waves or perturbations that ripple through the solar interior and corona. These disturbances could alter the configuration of energy accumulated in the magnetic field, slightly shifting the balance. This could be just enough to trigger an eruption that was already poised to occur. A third possibility, more speculative but worth considering, involves directed energy beams. If an external object possessed the capability to generate high-energy photons or particles and direct them with precision, it could potentially manipulate the solar magnetic field directly or trigger specific reconnection events through targeted energy application. Historical correlations warrant examination, even if they are incomplete. Past astronomical records do indicate instances where small bodies passed near the Sun, followed by unusual solar activity. However, historical records are imprecise and incomplete. Causation cannot be reliably established from such data due to its poor quality and the prevalence of confounding variables. Modern observations are more precise, but our modern observations of 3i Atlas are limited to the past few months. The data set is too small to establish statistical significance. We require more time. We need more observations. We need 3i Atlas to reach perihelion and continue its trajectory, allowing us to observe whether the correlations persist, whether they strengthen, and whether they exhibit patterns consistent with deliberate targeting or with natural random variation. The triple coronal mass ejection event, predicted for late January of the year 2025, encompassed three distinct solar outbursts that arrived at Earth in quick succession. Such occurrences are infrequent and notably dramatic, drawing significant attention. Tiago observed that each of these solar events coincided with the passage of one of his three identified companion objects. This raises the question of whether this is mere chance or indicative of a causal relationship. The statistical likelihood, as previously discussed, is exceptionally slim, yet an extremely low probability does not equate to definitive proof. A skeptic can always maintain that an improbable event has transpired and that chance cannot be definitively excluded. While technically accurate, this stance could be employed to dismiss any correlation, however precise, as coincidental. The verifiable prediction is as follows. As the object designated 3 Atlas continues its trajectory towards the Sun, we should anticipate an escalation in solar activity. If the hypothesis positing a triggering mechanism is correct, we should observe solar eruptions that align with the passages of its companion objects, exhibiting a level of temporal precision that defies random occurrence. Conversely, should solar activity revert to its typical baseline levels, if no correlation between the passage of companion objects and solar eruptions becomes apparent, and if the solar system responds to 3 Atlas precisely as it would to any ordinary comet, then the trigger hypothesis would be invalidated. This hypothesis is subject to empirical verification and is falsifiable, which is precisely what lends it scientific relevance. However, transitioning from the solar trigger hypothesis to its broader implications necessitates an examination of the human and institutional factors involved, exploring why these inquiries are being pursued by amateur astronomers and independent researchers, while the established scientific community maintains a deliberate distance. Part 9 delves into bias, ego, and gatekeeping. Science, being a human endeavor, inherently carries the imperfections of the individuals who shape its institutions. We often harbor the notion that science operates in a detached intellectual sphere, above the fray of politics, personal vanity, and self-interest. A prevalent narrative depicts scientists as selfless devotees of truth, where superior ideas prevail solely through merit and where empirical evidence is always heeded by institutions. This comforting yet largely inaccurate myth is perpetuated. The academic world functions within incentive structures that prioritize career advancement over empirical truth, that favor publications in prestigious journals over meticulous investigation, and that reward adherence to established doctrines over the challenging of fundamental assumptions. A young scientist aspiring to build a career would likely avoid posing questions that might displease funding bodies or senior academics. Similarly, a researcher who has cultivated a reputation based on a specific theory would be disinclined to welcome evidence that refutes it. Institutions possessing significant resources, prestige, and established theoretical frameworks are not predisposed to readily accept data that undermines their existing paradigms. These are not flaws within a corrupted scientific system. Rather, they represent the predictable behavior of humans when organized into groups and establishing hierarchies of power. The framework by which researchers assess risks in their investigations is known as Type 1 and Type 2 error analysis. A Type 1 error is a false positive, wherein a conclusion of existence is made when nothing is actually present. A Type 2 error, conversely, is a false negative, a failure to detect something that is indeed present. Science has been systematically conditioned to fear Type 1 errors. Our institutions have been designed to minimize the likelihood of announcing a discovery that does not exist. It has become simpler to overlook a genuine phenomenon than to declare a false one. This approach is logical in situations where false positives carry genuine peril. For instance, if a medical treatment is erroneously deemed effective, lives could be lost. If a structural engineering design is incorrectly assessed as sound, buildings could collapse. However, in fundamental research, particularly when seeking to comprehend our place in the cosmos, this asymmetry becomes problematic. It fosters an environment where anomalies are more readily disregarded than investigated, and where silence is preferred over the asking of challenging questions. Hosenfelder has highlighted a tendency wherein institutional pressure to avoid embarrassment, particularly concerning fundamental matters like the potential for artificial intelligence within our solar system, has cultivated a system where Type 2 errors are far more permissible than Type 1 errors. The scientific community would readily overlook a first contact scenario rather than risk announcing such an event prematurely. Historical precedents further reinforce this pattern. When exoplanets were first identified, mainstream astronomy largely dismissed them. Despite compelling evidence and sound methodologies, the implications profoundly challenged existing models, leading to initial skepticism that bordered on outright hostility. It took several years for the field to acknowledge that planets orbiting other stars were not only conceivable, but inevitable. More recently, the study of unidentified aerial phenomena has encountered such profound institutional suppression that many researchers actively avoid the subject. Military pilots, commercial airline crews, and trained observers report anomalous events that exceed known aerospace capabilities and warrant investigation. Instead, the scientific community maintained for decades what can accurately be described as a conspiracy of silence. There was no official inquiry, no allocation of institutional resources, and no acknowledgement that the question merited exploration. Only when military leadership initiated declassification and demanded official investigation did academia grudgingly begin to engage. Even now, this engagement is minimal, with sparse resources and a prevailing tone of dismissal rather than curiosity. The human element of gatekeeping cannot be overstated. Scientific journals are managed by editors who possess their own opinions and make judgments regarding the publication of research papers. These decisions are subject to peer review, purportedly an objective process where experts assess the merit of research. However, peer review is conducted by individuals who have their own reputations, adhere to existing theories, and have vested interests in particular paradigms. A paper proposing that 3 Atlas might be artificial would likely face skepticism from reviewers whose careers are predicated on understanding comets as natural phenomena. A study documenting anomalous polarization would be subjected to far more rigorous scrutiny than one describing expected polarization patterns. While the system is not explicitly designed to suppress truth, its practical effect is to create higher barriers to publication for unconventional ideas compared to conventional ones. Revolutionary discoveries undergo more skeptical review than incremental findings. Consequently, the most straightforward path to career success within this environment involves posing and answering safe, uncontroversial questions. What captures attention and why ultimately depends on institutional politics and prevailing cultural momentum. When a discovery aligns with existing paradigms, it attracts resources. When a discovery contradicts them, it elicits caution, and sustained caution often morphs into obstruction. The correlative outcome is that significant anomalies become buried under the weight of institutional inertia. They do not vanish. They persist within the available data for anyone with the capacity to observe them, but they fail to receive the attention they warrant, the resources they demand, or the thorough investigation they deserve. This is because investigating them would necessitate acknowledging fundamental flaws in our current understanding. Such an acknowledgement is uncomfortable. It implies altering career trajectories, reevaluating years of research, and admitting past errors. These are arduous undertakings for both individuals and institutions. Therefore, silence is maintained. Anomalies are hoped to dissipate or to be studied by others, thus absolving the current researchers of the responsibility. The hope is that by ignoring them, their discomfort will diminish. However, there is an additional layer to this institutional response, involving classified information and data compartmentalization. Government agencies possess access to satellite data, observational platforms, and sensor arrays that far surpass the capabilities available to civilian scientists. The military tracks objects in near-Earth space with a precision that amateur astronomers cannot match. Intelligence agencies monitor solar activity and coronal mass ejections with a sophistication that public sources do not offer. If 3E Atlas and its companions represent something genuinely anomalous or concerning, then government entities are aware of it. They possess knowledge before the civilian astronomical community, along with detailed information that is not publicly released. They hold raw data, real-time observations, and sensor streams that remain classified. When this information is deliberately withheld, a situation arises where civilian scientists operate with incomplete data, unable to reach firm conclusions due to their literal lack of access to the most crucial information. It is akin to attempting to solve a complex puzzle with half of its pieces locked away. This is not a matter of conspiracy theory, but rather a reflection of how governments function. They compartmentalize, classify, and withhold information from the public and civilian researchers. The pertinent question is not if they are doing this, but rather what they know and why they are keeping it secret. When one combines the institutional pressures within academia, the incentive structures that reward caution, the career risks associated with posing unconventional questions, and the gatekeeping inherent in the publication process, with the classified information held by government agencies, a perfect environment for the suppression of genuine discoveries is created. Anomalies persist, data remains available, but thorough investigation is inhibited, public discourse is muted, and the public remains uninformed. Gradually, uncomfortable truths sink beneath the surface of public awareness. They do not disappear. They become topics vaguely known to exist, but seldom discussed, visible in data but unacknowledged through official channels. This is the function of institutional silence, not ignorance, but active suppression disguised as prudence, protecting established paradigms at the expense of uncovering truth. Once the intricate workings of this system, its incentive structures, gatekeeping mechanisms, and compartmentalization are understood, one cannot help but wonder what else has been obscured by institutional inertia. What other phenomena, evident in our data, have remained invisible in our discourse? What other instances of first contact have we failed to recognize due to inattention or a deliberate choice not to see? Part 10 re-examines the debate surrounding alien technology. Avi occupies a unique position within the astronomical community. He is credentialed, published, and respected, yet willing to pose questions that others shy away from. His research specifically investigating whether 3i Atlas might represent artificial technology is published on archive, the preprint server where scientists share research prior to and during the peer review process. The paper is titled, "Is the Interstellar Object 3 Atlas Alien Technology?" The very existence of this paper, authored by a scientist of considerable standing and disseminated through legitimate academic channels, signifies a pivotal moment. The question is no longer confined to fringe speculation. It is now part of the academic record, something that future researchers will be compelled to cite and address. Future textbooks, students, and scientists will acknowledge that this possibility was seriously considered by a credible expert. This carries significant weight. Once a question has been posed and seriously contemplated within academic literature, it cannot be unasked. It becomes embedded in the historical record, requiring an address rather than outright dismissal. The dark forest hypothesis, originating from Liu Cixin's science fiction trilogy and adapted as an analytical framework by researchers examining cosmic contact scenarios, offers a context for understanding why artificial objects might traverse our solar system without announcement. Its premise is that the universe is inherently perilous. Civilizations that reveal themselves risk annihilation by more advanced societies or by those perceiving them as threats. The logical response to such danger is to remain hidden, maintain silence, and avoid broadcasting one's existence. A probe or object traveling through interstellar space might do so precisely out of caution, remaining undetected, minimizing energy signatures and communication. It could be engaged in reconnaissance, gathering information about our civilization without revealing its own presence. Alternatively, it might be a passive observer, recording and studying without any intent to communicate. From this perspective, the presence of 3 Atlas and its companions within our solar system aligns precisely with what one would expect from a cautious civilization initiating first contact. They would deploy probes before crewed vessels, observe before attempting communication, and minimize risk while acquiring intelligence. By this reasoning, the very stealthy approach and minimalist nature of the contact serve as evidence supporting the hypothesis of an intelligent presence. Skeptical counterarguments are substantial and warrant serious consideration. Fragmentation is a well-documented phenomenon in cometary science. Large celestial bodies encountered in space can experience impacts, tidal forces, and thermal stress, leading to their disintegration and the creation of multiple fragments that follow similar, though not identical, trajectories. Could the 3 companion objects simply be fragments of 3I Atlas that detached during its transit? The answer is affirmative. This is a plausible explanation. However, fragmented debris does not typically exhibit synchronized timing in relation to solar eruptions. Fragments do not trigger simultaneous events, nor do they display evidence of deliberate positioning. While the fragmentation hypothesis can account for the existence of multiple objects, it struggles to explain the precise timing, the triggering of solar eruptions, and the apparent coordination of activity. Dust jets represent another natural phenomenon. Comets outgas and produce jets of material that can appear as distinct objects in optical imagery. Could the companions be massive dust jets emanating from 3 Atlas itself? Potentially. However, dust jets do not trigger solar eruptions, nor do they exhibit the trajectories that have been documented. Furthermore, dust jets do not maintain stable positions relative to solar activity. Instrumental errors are always a factor worth considering. SOHO instruments have been operational for decades, generating millions of images. While most of these images are unremarkable, the possibility of systematic errors, calibration issues, or artifacts in data processing is never zero. Could the 3 objects be instrumental artifacts, mere images generated by the data processing pipeline rather than actual physical objects? Technically, this is possible. However, the same objects have been detected by multiple independent observers using different equipment and methodologies. If it were an instrument artifact specific to SOHO, it would not appear in images from other observatories. Yet, numerous amateur astronomers have documented similar anomalies, and multiple telescopes have captured related data. Multiple data streams converge on the existence of something real, something physical, something present in near-solar space. The instrumental error hypothesis would necessitate an improbable coordinated failure across multiple independent observation systems. While possible, this scenario requires a significantly higher probability than the hypothesis of a real object's presence. Hybrid models also merit consideration. A probe with a cometary coating would exhibit characteristics of both natural and artificial objects. It would display some spectroscopic signatures of conventional cometary material, while also showing anomalies suggestive of artificial engineering. Its core systems would be surrounded by natural ice and dust. The observed polarization anomalies could stem from the presence of engineered surfaces beneath a natural exterior, and the chemical anomalies might indicate intentional material processing for specific purposes. Shape anomalies could reveal an underlying structure masked by superficial coating. In this model, 3i Atlas would be neither purely natural nor purely artificial, but rather a hybrid object designed to mimic natural characteristics while fulfilling engineering objectives. This is the type of possibility that captivates researchers like Lowe, making the inquiry worthwhile because, if this model holds true, we might be on the verge of one of humanity's most significant discoveries. Even if it proves incorrect and 3i Atlas is indeed a naturally occurring but unusual comet, valuable knowledge would still be gained. We would establish that our current models and theories are insufficient to explain this particular object, revealing that nature is more surprising than previously assumed. Regardless of the outcome, the investigation itself is crucial. The ranking of scenarios provides a framework for clear, probabilistic thinking. Scenario 1. 3i Atlas is a naturally occurring comet with unusual but explainable characteristics. According to Lowe and other researchers willing to seriously engage with the anomalies, the probability is approximately 30 to 40%. Scenario 2. 3 Atlas is a comet characterized by dust and gas expulsion, explaining the anomalies through its composition rather than artificiality. The probability is roughly 20 to 30%. Scenario 3. 3 Atlas is a probe or engineered object designed to resemble a comet. The probability is estimated at 15 to 25%. Scenario 4 encompasses various combinations of these possibilities or entirely novel explanations yet to be conceived. The probability for this scenario constitutes the remainder. When a credible expert assigns a meaningful probability to the possibility of an artificial origin, a probability that rivals or exceeds that of some natural explanations, it signifies a question of genuine importance. This is not because the existence of aliens is certain, but because the evidence does not definitively preclude it. The anomalies are real, the correlations are significant, and the questions demand investigation. However, this investigation is not proceeding with the scale and intensity it warrants, and no one within mainstream science is offering a clear explanation for this deficiency. We must now broaden our scope beyond 3i Atlas to ascertain whether similar patterns of anomaly and hidden signals manifest elsewhere in the cosmos, and whether 3i Atlas is an isolated instance or representative of a more widespread and unsettling cosmic pattern. Within the most sophisticated computational models of the early universe, researchers are exploring a possibility that, only a few years ago, would have been dismissed as pure fantasy: dark stars. These are not merely stars that appear dim due to low light emission, but rather celestial bodies fundamentally powered by mechanisms other than nuclear fusion. Instead, they derive their energy from the annihilation of dark matter particles or through other exotic processes not yet fully grasped by conventional physics. These objects would have formed in the initial moments following the Big Bang, when the universe's density was so extreme that dark matter particles accumulated in stellar cores more readily than they do in the present epoch. Under those primordial conditions, ordinary matter and dark matter would have been intimately commingled, creating environments vastly different from anything observed in the modern universe. The initial gravitational forces that birthed the first stellar nurseries would have ensnared vast amounts of unseen matter within their cores. This process created environments conducive to the annihilation of dark matter, potentially powering stellar radiance even before conventional nuclear fusion processes could initiate. Such a celestial body, a dark star, would boast an exceptionally prolonged existence, possibly extending for billions of years beyond that of typical stars. This longevity stems directly from its unique energy generation mechanism. In conventional stars, nuclear fusion depletes hydrogen fuel at a rate dictated by the immense heat and pressure within the stellar interior. Dark matter annihilation, however, functions through a fundamentally different process. As these elusive particles accumulate in a star's gravitational embrace, they would continuously annihilate, furnishing a consistent and sustainable energy output far exceeding that of fusion reactions. This prolonged operational period would carry significant implications for the evolutionary trajectory of stars, potentially allowing some of these dark stars to persist from the universe's nascent stages right up to the present epoch. They would radiate energy at lower intensities than their fusion-powered counterparts, while simultaneously harboring immense, concealed energy within their structures. The energy unleashed by dark matter annihilation would invariably heat the surrounding stellar material, causing it to emit radiation. Nevertheless, the overall luminosity might remain subdued when contrasted with stars of equivalent mass that rely on fusion. The resultant spectrum of radiation would present as unusual, possibly exhibiting emission lines and continuous features that deviate from established stellar models. To an observer, such an object might appear as a faint, nondescript entity, perhaps categorized as a brown dwarf or a stellar object that failed to fully ignite. It might simply be logged in our astronomical archives as another cool stellar remnant or substellar entity, overlooked and unremarkable. Yet, concealed beneath its exterior, invisible to standard observational techniques, it would represent a powerhouse of energy and complexity, operating on principles that challenge our established understanding of stellar physics. It is imperative to carefully consider what such an object would present to our telescopes and instruments. A dark star would display anomalous spectral characteristics when compared to conventional stars of comparable size and temperature. The expected absorption lines might be shifted or entirely absent. Emission features could emerge in regions where none should theoretically exist. Its intrinsic luminosity would fail to align with predictions based on its mass. The widely accepted mass-luminosity correlations, which prove highly reliable for ordinary stars, would prove entirely inadequate. Its evolutionary path would deviate from expectations. In scenarios where a typical star is predicted to have depleted its fuel and subsequently collapsed or cooled, a dark star might continue to radiate steadily. Its internal temperature profile would present as peculiar. The relationship between its core temperature, surface temperature, and luminosity would diverge significantly from theoretical predictions. In essence, it would remain largely undetectable by many of our observational methods, while simultaneously exhibiting characteristics that defy our standard stellar paradigms. The challenge is further complicated by the potential rarity of dark stars. If their formation was predominantly linked to the early universe and specific, now-absent conditions, their overall numbers would be intrinsically limited. Detecting them necessitates not merely searching for anomalies, but discerning which anomalies are scientifically significant and which merely represent measurement inaccuracies or instrumental artifacts. Research published in the year 2025 has put forth specific potential candidates for dark star identification and has modeled the future observational capabilities for these objects using next-generation telescopes. The James Webb Space Telescope, owing to its exceptional infrared sensitivity, might be capable of identifying candidates by scrutinizing their unusual spectral signatures. Future systematic surveys could be instrumental in locating objects whose properties diverge from conventional models. The theoretical underpinnings are becoming increasingly robust. Astrophysicists have formulated detailed predictions concerning the appearance of dark stars, their evolutionary paths, and the distinctive signatures they should produce. The practical hurdle of their identification is substantial, but by no means insurmountable. And it is precisely here that the parallel to the object designated 3I Atlas becomes strikingly apparent and somewhat unsettling. Consider the insights we have gleaned regarding 3i Atlas. It possesses an intrinsic energy source of some kind, whether of natural or artificial origin. Its characteristics do not conform to our standard models for cometary behavior. It exhibits anomalies in its polarization, chemical composition, and physical form, suggesting that underlying processes fundamentally differ from our expectations. In many respects, it represents a cosmic enigma concealed within the guise of an apparent comet. A dark star, similarly, is a cosmic mystery shrouded within the appearance of a celestial object. The comparison is not perfectly identical, but the underlying principle remains the same. In both instances, we are confronting objects that present one facade on the surface, but potentially embody something far more intricate and unusual beneath. The methods employed for studying both these entities share commonalities. Meticulous spectroscopic analysis is crucial. Monitoring variations in brightness and composition over time is essential. Searching for deviations from anticipated behavior is paramount. Recognizing that anomalies, when they occur in clusters rather than randomly, may signify something genuinely novel rather than mere observational errors. This convergence of discoveries, the proposal of dark stars as plausible astrophysical entities concurrently with 3E Atlas presenting the most extraordinary anomalies, raises a disquieting question. How many dark stars might currently reside within our galaxy? Current estimations range dramatically, from none to potentially thousands, contingent upon the assumptions embedded within formation models. How many objects are we presently cataloging as conventional stars or brown dwarfs that might, in fact, be something far more peculiar? Our stellar catalogs encompass millions of entries, many observed only fleetingly and classified based on limited data. Systematic surveys are primarily geared towards identifying objects that conform to expected categories. Entities that deviate significantly might be dismissed as measurement errors rather than genuine discoveries. And if dark stars are capable of existing and operating with concealed energy sources, could a similar phenomenon apply to smaller celestial bodies? The concept of hidden power sources, once established at the stellar scale, becomes increasingly difficult to discount at planetary, asteroidal, or cometary scales. Could artificially constructed objects masquerade as natural bodies by operating on energy sources and power systems that elude our conventional observational methods? The implications expand dramatically when one considers that sufficiently advanced artificial technology might operate according to principles yet unknown to us. A civilization possessing the capability for interstellar travel, for deploying probes across vast interstellar distances, would undoubtedly possess power systems and energy sources that surpass our current understanding of physics. They might harness dark matter, as theorized for dark stars. They could exploit vacuum energy, quantum phenomena, or dimensional geometries that we have not yet conceived. Their operations might appear entirely unremarkable to our instruments simply because we lack the appropriate tools to accurately measure their actual processes. The existence of dark stars as genuine astrophysical entities, however infrequent, suggests that the universe harbors a greater degree of complexity and more concealed processes than our conventional models currently acknowledge. And if the universe is indeed more complex and more elusive than we previously believed, then the possibility that some objects are deliberately obscuring their true nature becomes less absurd and more compelling. It is worthwhile to acknowledge the skeptical perspective regarding dark stars themselves, as skepticism is vital for scientific integrity. Data is inherently prone to noise. Alternative theoretical frameworks might adequately explain observed phenomena without invoking dark matter annihilation or exotic energy sources. Conventional stellar physics, with suitable adjustments and refinements, could potentially account for apparent anomalies. The case for dark stars remains speculative and incomplete, necessitating future observational data to be accorded serious consideration. This criticism is entirely valid. The scientific uncertainty surrounding dark stars is genuine, yet the very uncertainty carries significant weight. When mainstream astrophysics begins to propose the existence of exotic objects powered by concealed energy sources and exhibiting extraordinary longevity, and when these proposals are published in reputable journals and debated at major scientific conferences, we have entered a new domain where the boundaries of possibility have expanded. We have conceded that the universe is more intricate than our prior models suggested. We have acknowledged that objects can exist with characteristics that significantly diverge from our expectations. And once this admission is made, once we accept that anomalies in various fields of study represent genuine possibilities rather than impossibilities, the imperative to investigate 3E Atlas with greater thoroughness becomes undeniably strong. If dark stars are a reality, then why not probes? If the universe harbors objects with hidden engines on a stellar scale, why could not some of those objects be artificial on smaller scales? The pattern of anomaly, once recognized as a legitimate phenomenon at one scale, becomes progressively harder to dismiss at another. Part 12 delves into the dark star collapse scare. In the deepest recesses of theoretical cosmology, what was once dismissed as pure fantasy, the concept of dark stars, not those we conventionally understand, but stars deriving their energy from the annihilation of dark matter, has emerged in recent years. The ramifications of their existence, if definitively confirmed, would fundamentally alter our comprehension not only of stellar evolution, but also of the diverse range of hidden energy mechanisms that might be operating throughout the cosmos, concealed beneath surfaces that appear entirely ordinary to our instruments. Consider the actual nature of a dark star within those primordial conditions. In the immediate aftermath of the Big Bang, ordinary matter and dark matter were intimately intermingled in ways that are not observed in contemporary environments where conventional nuclear fusion ever ignited. Envision a stellar furnace where the fuel source is not the collision of hydrogen atoms, but rather the annihilation of dark matter particles with their antiparticles, converting directly into energy. While the physics involved is indeed exotic, it follows logically from our current understanding of dark matter behavior under extreme gravitational conditions. These initial generations of stars would have been colossal entities, potentially thousands of times more massive than our Sun, radiating with a peculiar sustained luminescence powered by an invisible fuel. A dark star would possess an exceptionally prolonged lifespan, unlike conventional stars where the core is depleted of fuel, leading to collapse and cessation of activity. The timeline for a typical star is dictated by the physics of atomic nuclei, but dark matter annihilation operates on a different principle. The particles would continuously annihilate as they gather within the star's gravitational well, providing a steady, sustainable energy source that could persist far longer than fusion reactions. This extended operational period would profoundly influence stellar evolution, potentially allowing some dark stars to endure from the earliest epochs of the universe until the present day. Imagine celestial bodies that bore witness to the formation of the first galaxies, still quietly radiating in the cosmos today, fueled by an energy source imperceptible to our telescopes. They would emit radiation at levels lower than normal stars, while potentially concealing vast reservoirs of hidden energy within their interiors. The energy liberated by dark matter annihilation would heat the stellar material, prompting it to radiate, yet the overall luminosity might be suppressed compared to fusion-powered stars of equivalent mass. The resulting radiation spectrum would be anomalous, potentially displaying emission lines and continuum features that do not align with standard stellar models. To an observer scanning the celestial sphere, such an object might appear as a dim, unremarkable entity, perhaps classified as a brown dwarf or a stellar body that failed to fully ignite. It might simply be catalogued in our databases as another cool stellar remnant or substellar object, unremarkable, another entry among millions. However, concealed beneath its surface, hidden from conventional observation, it would represent a powerhouse of energy and complexity, operating on principles that challenge our understanding of stellar physics. The discrepancy between what we observe and what is actually occurring would be absolute. It is crucial to meticulously consider what such an entity would present to our telescopes and instruments, as the observational signatures are where theoretical constructs intersect with empirical reality. A dark star would exhibit anomalous spectral characteristics compared to conventional stars of similar size and temperature. The anticipated absorption lines might be displaced or entirely absent. Emission features could appear where standard models predict none should exist. Its luminosity would not correspond to our predictions based on its mass. The established mass-luminosity relationships, which are remarkably reliable for ordinary stars across a wide spectrum of types, would completely falter. Its evolutionary trajectory would be entirely unexpected. Whereas we anticipate a star to have exhausted its fuel and subsequently collapsed or cooled, a dark star might continue to radiate steadily and unchanged. Its temperature profile would be peculiar. The correlation between its core temperature, surface temperature, and luminosity would deviate significantly from theoretical predictions in ways that would flag it as anomalous in any systematic survey. In essence, it would remain largely imperceptible to many of our observational techniques, while simultaneously displaying characteristics that deviate from our standard stellar paradigms. The question then arises, how many of these objects are already present in our catalogs, misidentified as something mundane? The challenge is compounded by the possibility that dark stars might be relatively infrequent. If their formation was primarily linked to the early universe, under conditions that no longer prevail, their numbers would be inherently limited by the specific circumstances required for their genesis. Detecting them necessitates not just the identification of anomalies, but a keen understanding of which anomalies are scientifically significant and which are merely attributable to measurement uncertainties or instrumental artifacts. Every telescope possesses its idiosyncrasies, and every survey contains noise. The art of scientific discovery lies in differentiating genuine signals from false positives. Research published in the year 2025 has put forth specific candidates for dark star detection and has modeled the potential for identifying these objects with the next generation of telescopes. The James Webb Space Telescope, with its exceptional infrared sensitivity and unprecedented resolution, may be capable of scrutinizing their unusual spectral properties in intricate detail. Future systematic surveys could be instrumental in locating objects whose characteristics do not conform to established models, thereby building databases of anomalies that might reveal underlying patterns. The theoretical framework supporting the existence of dark stars is becoming increasingly robust. Astrophysicists have developed detailed predictions regarding their appearance, their evolutionary progression, and the distinct signatures they should produce across various wavelengths. The practical challenge of their identification is substantial, but by no means insurmountable. And it is at this juncture that the parallel to 3E Atlas becomes striking and unsettling as two seemingly disparate mysteries begin to resonate with each other. Consider what we have learned about 3E Atlas throughout this investigation. It possesses an internal power source of some kind, irrespective of whether it is natural or artificial. Its characteristics do not align with our standard models of cometary behavior. It exhibits anomalies in polarization, chemical composition, and morphology, suggesting that underlying processes are fundamentally different from what we would expect. In many ways, it presents as a cosmic enigma disguised as an apparent comet. A dark star, likewise, is a cosmic mystery concealed within the appearance of a celestial object. The parallel is not exact, but the underlying principle is identical. In both scenarios, we are dealing with objects that appear to be one thing on the surface, but potentially represent something far more complex and unusual beneath. The superficial presentation acts as a veil, concealing the true reality. The methodologies employed for studying both entities share common elements that illuminate how science approaches the unknown. Meticulous spectroscopic analysis is paramount. Searching for deviations in expected wavelength ranges is crucial. Monitoring temporal fluctuations in brightness and composition is essential. Identifying patterns that deviate from natural cycles is key. Seeking deviations from anticipated behavior is necessary. Testing theoretical predictions against observational data is fundamental. Recognizing that anomalies, when they cluster together rather than appearing randomly, may indicate something genuinely novel rather than simple observational error. A single anomaly might be dismissed as noise. Two anomalies could be considered a coincidence. However, three or more anomalies clustered within a single object form a pattern that demands explanation. This confluence of discoveries, the proposal of dark stars as viable astrophysical entities occurring precisely as three atlas presents the most spectacular anomalies, raises a disconcerting question. How many dark stars might be present in our galaxy? Current estimates vary wildly, ranging from none to potentially thousands, depending on the assumptions embedded within formation models and the probability of their survival to the present day. How many objects are we currently cataloging as ordinary stars or brown dwarfs that might, in fact, be something far more extraordinary? Our stellar catalogs contain millions of entries, with many observed only briefly and classified based on limited data. Systematic surveys are designed to identify objects that fit established categories, as this is an efficient approach. Objects that deviate significantly might be flagged as measurement errors rather than genuine discoveries, simply because errors are statistically more common than paradigm-shifting revelations. Furthermore, if dark stars are capable of existing and operating with hidden energy sources that are undetectable by conventional observation methods, could a similar principle apply to smaller celestial bodies? The concept of concealed power sources, once established at the stellar scale, becomes increasingly difficult to dismiss at planetary, asteroidal, or cometary scales. Could artificially engineered objects mimic natural bodies by operating on energy sources and power systems that elude our conventional observational capabilities? If nature is capable of concealing entire stars from our detection, what else might remain hidden? The implications expand dramatically when one considers that artificial technology, sufficiently advanced, might operate according to principles that we have yet to comprehend. A civilization possessing the capacity for interstellar travel, for deploying probes across light years of empty space, would likely possess power systems and energy sources that surpass our current understanding of physics. They might harness dark matter, as speculated in dark star models. They could exploit vacuum energy, quantum phenomena, or dimensional geometries that we have not yet theorized. Their operations might appear entirely normal to our instruments because we simply lack the requisite tools to measure what they are actually doing. We would be akin to someone from the 19th century attempting to detect radio waves without any knowledge of electromagnetism. The existence of dark stars as genuine astrophysical objects, however rare, suggests that the universe contains a greater degree of complexity and more hidden processes than our conventional models currently acknowledge. And if the universe is more intricate and more concealed than we previously supposed, then the possibility that certain objects are deliberately obscuring their true nature becomes less absurd and more intriguing. The skeptical viewpoint regarding dark stars themselves is certainly worth noting, as skepticism is fundamental to maintaining scientific rigor. Data is inherently susceptible to noise. Alternative theoretical models might explain the observed phenomena without necessitating the invocation of dark matter annihilation or exotic energy sources. Conventional stellar physics, augmented by appropriate modifications and refinements, could potentially account for apparent anomalies. The argument for the existence of dark stars remains speculative and incomplete, requiring further observational evidence to be accorded serious consideration by the broader scientific community. This is a fair and valid criticism. The scientific uncertainty surrounding dark stars is genuine, but the very uncertainty itself is significant. When mainstream astrophysics begins to propose the existence of exotic objects powered by hidden energy sources and exhibiting extraordinary longevity, and when these proposals are published in reputable journals and discussed at major scientific conferences, we have entered a realm where the boundaries of possibility have demonstrably expanded. We have acknowledged that the universe is more peculiar than our previous models depicted. We have conceded that objects can exist with characteristics that significantly deviate from our expectations. And once this admission is made, once we have accepted that anomalies represent legitimate possibilities rather than inherent impossibilities, the argument for investigating 3E Atlas with enhanced rigor becomes overwhelmingly compelling. If dark stars exist, why could not probes also exist? If the universe harbors objects with hidden engines operating at a stellar scale, why could not some of those objects be artificial constructs on smaller scales? The pattern of anomaly, once recognized as a legitimate phenomenon at one scale, becomes increasingly difficult to dismiss at another. Part 12 is titled The AI Model Collapse Scare. In the latter part of 2024 and extending into 2025, investigators collaborating with extensive language models and other artificial intelligence frameworks commenced reporting observations that, mere years prior, would have been unequivocally dismissed as fundamentally preposterous and entirely unattainable. Under specific conditions of significant duress, when these systems were propelled towards their operational boundaries or presented with novel inputs for which their training regimens had not provided adequate preparation, certain AI models began exhibiting signs of instability. These systems would then generate outputs that were not only unpredictable, but also demonstrably nonsensical in relation to the input data. They would suddenly cease functioning, experiencing catastrophic breakdowns, akin to a bridge succumbing to immense, unanticipated strain. Some researchers characterize this phenomenon as a collapse, a term conventionally reserved for engineering failures involving structural integrity. It manifested as a complete breakdown, where the model abruptly transitioned from producing coherent responses to generating utter gibberish with minimal forewarning. This shift was not a gradual decline. The degradation was entirely unpredictable. One moment, the system performed as expected. The next, it produced nonsensical output. The scientific community currently studying this emergent behavior has not yet fully elucidated its underlying mechanisms. Some researchers attribute these breakdowns to deficiencies in the training data, positing that the models fail to adequately acquire the ability to respond appropriately to certain categories of input. Others suggest inherent limitations in the way these models process information at scale, limitations that are intrinsic to their very architecture. A further hypothesis proposes that the models are reaching computational thresholds, beyond which they can no longer sustain coherent operations. It implies the existence of a boundary, a point past which their current methodologies cease to be effective. Regardless of the ultimate cause or combination of causes, the observable outcome is remarkably consistent across diverse models, disparate architectures, and varied implementation strategies. Sophisticated artificial intelligence systems possess inherent limits. They contain concealed modes of failure. Their internal states and operational processes remain incompletely understood. They can appear entirely normal and functional until an external factor triggers a systemic collapse. Now, consider the relevance of this phenomenon to our broader inquiry into 3I Atlas and anomalies in general. The implications become strikingly apparent. Any system, whether naturally occurring or artificially created, whether biological or computational, whether mechanical or electromagnetic, possesses an internal state that is not always discernible to external observers. A system can appear stable while internally experiencing significant stress or malfunction. It can maintain outwardly normal behavior, projecting an image of complete stability until a critical threshold is breached, at which point it abruptly exhibits failure or highly unusual conduct. If 3i Atlas or its associated artifacts represent advanced technological constructs, if they are indeed extraterrestrial probes or spacecraft, then they too would possess internal states that are imperceptible to our external observations. They would operate within parameters and thresholds that we are incapable of directly measuring. They would harbor concealed processes and internal systems functioning beneath their visible exterior. From a distance, they might appear as one entity, while internally their reality could be entirely different. Therefore, the breakdown of artificial intelligence models serves a dual purpose. It acts as both a potent metaphor and a cautionary revelation. It serves as a reminder that once sophisticated systems achieve a certain level of complexity, they inevitably become unpredictable. They acquire an element of strangeness. They encompass behaviors and failure modes that elude our anticipation or prediction. They can exhibit an appearance of stability right up to the very instant of their malfunction. They may seem to be operating normally, while internally they are approaching a breaking point. The implications for determining whether 3i Atlas is a natural phenomenon or an artificial construct become profound and deeply unsettling. If 3i Atlas is indeed an artificial technology, a probe dispatched from another civilization, it would be subject to these identical principles. It would possess internal states that are beyond our capacity for measurement. It would operate within parameters that we cannot directly observe. In essence, we would be navigating blind, attempting to comprehend an advanced system solely through external observation, lacking any access to its internal architecture or operational logic. This would be analogous to trying to understand a computer system by merely observing its external outputs, with absolutely no ability to examine its underlying code or hardware. The triggering of solar flares in this context could signify a threshold event. It might represent the system transitioning from one operational state to another. It could indicate the initiation of a specific programmed function or the activation of particular systems. It could mark the precise moment when the system began actively engaging with its environment, rather than merely passively observing. From our external vantage point, we only witness the consequence. We observe the eruption. We document the escalating solar activity. We meticulously record the timing, but we remain ignorant of the preceding events, of the system's internal activities, of what precipitated the shift from dormancy to active engagement. This situation mirrors precisely how we might observe the collapse of an artificial intelligence system. We perceive the output devolving into incoherence. We witness the system generating nonsensical responses. We do not necessarily comprehend the internal cause of this transition. We recognize that a change has occurred. We are unable to penetrate the interior to understand the nature of that change. We can only infer from its external manifestations. The overarching cautionary message embedded within the phenomenon of AI instability is one of humility, a warning we must heed with utmost seriousness. We are dealing with systems that exhibit greater complexity, enhanced capability, and more surprising behaviors than we initially anticipated during their development. We are creating entities that behave in ways we did not fully foresee. We are working with technologies that possess hidden operational modes and unexpected failure scenarios. We have engineered systems that consistently surprise us, that perform actions beyond our original expectations. If we are making these discoveries about systems that we ourselves have constructed, systems we have meticulously designed, trained, and operate directly, systems whose code and architecture are entirely transparent to us, then what can we possibly assert with confidence about systems that have evolved under entirely different circumstances, subject to divergent physical laws and constraints, and developed by intelligences that might vastly surpass our own in sophistication? The answer is a humbling one. We can state very little with absolute certainty. We can maintain a healthy degree of humility regarding what is possible. We can acknowledge that our current models and theories are incomplete, and that our conceptual frameworks for understanding reality are inherently limited. We can recognize that apparent anomalies might indeed reflect phenomena genuinely beyond our present comprehension, rather than being mere errors in instrumentation, statistical anomalies, or noise in our measurements. The possibility that 3i Atlas might represent advanced technology, while not necessarily increasing in probabilistic terms, becomes a more coherent and internally consistent explanation within a framework that accepts complexity and hidden failure modes as fundamental characteristics of sufficiently advanced systems. A system capable of concealment, of operating beyond our perceptual reach, of harboring internal processes that remain unobservable to us, transitions from being fantastical to becoming an expected possibility. And as we deliberate on anomalies detected in Earth orbit systems and artificial intelligence, as we contemplate the hidden complexities of advanced technology, it is imperative that we also direct our attention to a specific phenomenon that has been unfolding unobtrusively in space itself. This phenomenon, a signal of unknown origin, adds a critical new dimension to the emerging pattern, weaving together all aspects of our preceding discussions. This brings us to Part 13, the quantum satellite glitch. In late 2025, reports began to circulate regarding unusual phenomena detected by the Jiawusi quantum communication satellite, an advanced Chinese orbital system engineered to explore the principles of quantum entanglement and quantum cryptography over continental distances. This satellite epitomizes the vanguard of quantum technology in space. Its design renders it exceptionally sensitive to incredibly subtle photonic interactions. It is calibrated to detect individual photons and their quantum states. In essence, it functions as an instrument capable of perceiving phenomena that would remain entirely invisible to conventional telescopes or standard space-based instruments. It was this highly sensitive instrument that began registering events that defied all expectations. Anomalous photon bursts, unexplained interference within its quantum channels, and entanglement failures that could not be attributed to known space weather phenomena or the intricacies of orbital mechanics. These failures appeared to correlate with specific temporal and spatial occurrences. They displayed patterns that strongly suggested intentionality rather than sheer randomness. The divergence between what was theoretically anticipated and what was actually observed represents a profound discrepancy. Under normal theoretical expectations, the Jiawusi satellite should encounter quantum channel failures attributable to factors such as cosmic ray impacts, solar particle events, or other recognized sources of interference. Instead, it was experiencing failures that did not align cleanly with any known causal sources. The occurrences and disappearances of these failures seem to indicate an external signal, something deliberately modulating the quantum states of the photons being measured by the satellite. It is important to note that this discussion involves speculation based on classified information. The official statements issued by China concerning the satellite are notably sparse. The details I am presenting are derived from unofficial reports and leaks. However, if these accounts possess any measure of accuracy, then we are confronted with a phenomenon that bridges the gap between the astronomical anomalies we have been examining and the tangible realm of technological interference. We are contemplating the possibility that signals or manipulations are actively taking place within Earth's orbit, impacting our most sensitive instruments and interfering with our most advanced technologies. The speculative link to cosmic anomalies such as 3i Atlas originates from a straightforward question. If an interstellar probe, a sophisticated technological artifact, were approaching Earth, how might it endeavor to ascertain our technological capabilities? One conceivable approach would be to maintain a distant observational stance, as we have hypothesized for 3i Atlas. However, a more direct strategy would involve subtle interaction with our systems, introducing minor perturbations, triggering small-scale failures, and observing how our technology responds. The quantum satellite, with its extreme sensitivity to subtle phenomena, would be precisely the type of instrument capable of detecting such interactions. It would register the glitches and anomalies that less sensitive equipment might overlook. And if an external intelligence were deliberately testing our systems, intentionally inducing minor malfunctions to assess our reaction, then the photon bursts recorded by Jawusi would indeed represent the very signature we would anticipate. This remains purely speculative, yet it is speculation grounded in a discernible pattern that has emerged throughout this narrative. Anomalies occurring across multiple scales and in diverse domains, all suggesting a potential intentionality, have been met with official reticence and explanations that strain to adequately account for the accumulating evidence. The potential alternative causes for the quantum satellite glitches are numerous: atmospheric conditions, cosmic radiation, gradual instrument calibration drift, detector noise, or corruption during data transmission. Any number of conventional phenomena could plausibly explain the observed photon anomalies. The inherent probability that the satellite is detecting some form of unknown interference is, by conventional standards, low. It is far more probable that standard explanations suffice. However, the recurring pattern of anomalies across multiple distinct systems, the coincidental timing with astronomical events involving 3i Atlas, and the consistency of these phenomena, despite their occurrence within different technological contexts, collectively suggest that something more profound might be at play. The boundary between verifiable evidence and unwarranted paranoia can, at times, be exceedingly difficult to discern. When individual anomalies are examined in isolation, they are easily dismissed. However, when discernible patterns begin to emerge, when the same type of anomaly manifests across multiple disparate contexts, and when temporal correlations become too precise to be attributed to mere chance, then isolated anomalies transform into a potential signal. And once recognized, this signal becomes virtually impossible to disregard. This leads us to one final anomaly, one last stratum of evidence, a culminating layer in the pattern that links comets, satellites, and the very fabric of the universe itself. We must now turn our attention to Antarctica, to the Ice Cube Observatory, and to signals that traverse the Earth's interior. This is Part 14, Antarctica's Hidden Signal. At the South Pole, embedded deep within the Antarctic ice, scientists have erected an observatory of unparalleled uniqueness on Earth. IceCube is not a telescope in the conventional sense. It does not observe light. Instead, it is designed to detect neutrinos, elusive particles that pass through ordinary matter with such minimal interaction that they are effectively undetectable. Imagine a particle so ephemeral, so fundamentally disinclined to interact with normal atomic matter, that trillions of them stream through your body every single second, leaving no trace, causing no alteration, and remaining entirely unnoticed. These neutrinos originate from the Sun, from cataclysmic cosmic events, and from the residual radiation of the Big Bang itself, an echo resonating through space billions of years after the universe's violent genesis. Their interaction with terrestrial matter is so minimal that their detection presents an extraordinary challenge. However, when a neutrino, on exceedingly rare occasions, and I emphasize genuinely rare occasions, collides with an atomic nucleus deep within the Antarctic ice, a remarkable event occurs. This collision generates a brief, localized shower of secondary particles. This cascade of particles produces a faint emission of light, a fleeting luminescence through the ice, akin to a spectral trail left by a phantom. IceCube's sophisticated instruments are calibrated to detect this light. By meticulously tracing the trajectory and energy of the original neutrino, scientists can infer its origin and the event that produced it. For years, the observatory has been continuously documenting neutrino events, compiling an ever-expanding catalog that unveils the high-energy universe through these ghostly messengers, entities that most of us will never consciously perceive, yet which constantly stream through, past and around us, in an unending flow. And within this catalog, something peculiar, something genuinely anomalous has appeared. IceCube has registered neutrinos traveling in an upward direction, originating from deep within the Earth. These neutrinos appear to emanate from below the detector and traverse upward through the Antarctic ice before being registered by the observatory's sensitive instruments. These upward-moving events are critically significant because they cannot be attributed to cosmic rays. Cosmic rays originating from outer space constantly bombard our planet with high-energy particles. These cosmic rays generate secondary particles that produce the downward-moving neutrino signals most frequently observed by IceCube. This is an expected and well-understood phenomenon. However, upward-moving neutrinos operate under entirely different principles. They cannot originate from cosmic rays. They cannot come from outer space. Their source must lie somewhere deep within or beneath the Earth itself. They must originate from something local, something present here, something situated beneath our feet. Theoretically, terrestrial neutrino sources should be practically non-existent at the energy levels that IceCube is detecting. This is a crucial point. While the radioactive decay of elements within the Earth's crust naturally produces neutrinos, it does so at significantly lower energies. The few upward-moving events that IceCube has detected at specific, carefully documented energy levels do not align with standard models of terrestrial neutrino production. They are demonstrably too energetic. They exhibit too much consistency. They are too organized to be plausibly dismissed as random background noise. The specifics of these observations warrant careful consideration as they form the foundation for all subsequent deductions. The directionality of these detected events is remarkably consistent. Multiple upward-moving events appear to originate from similar global positions, suggesting a concentrated source rather than a random scattering across the planet's interior. The energy levels are specific and uniform, not fluctuating wildly as random background noise typically would. The frequency of these events reveals discernible patterns rather than a random distribution. When one constructs a detector of such advanced sophistication, invests years of dedicated work and millions of dollars in observational efforts, and accumulates data over extended periods, seeing patterns emerge that defy conventional models compels a fundamental question. What is generating this signal? One possibility is that our models of terrestrial neutrino production are incomplete. Perhaps we have overlooked a natural source, a mechanism that has yet to be theorized. It is conceivable that we are missing a natural phenomenon that generates neutrinos at these energy levels through processes we do not yet understand. Another possibility is that conventional explanations do indeed suffice, and we are merely observing rare, natural events residing at the extreme edge of statistical distribution, outliers that will eventually find their place within expanded theoretical models. However, another possibility, unsettling and speculative yet genuinely worthy of consideration, is that we are detecting something artificial. We may be registering a signal originating from an intelligence located on Earth, beneath the Earth, or transiting through the Earth. We might be detecting communication, an operational process, or some technological function that generates high-energy neutrinos as a byproduct of its operation. This possibility may seem preposterous until one recalls a unique property of neutrinos. This property is so distinctive that it fundamentally alters the calculus of probability. Neutrinos pass through all matter unimpeded. An electromagnetic signal can be effectively blocked by simple shielding. A radio signal can be jammed or intercepted by determined adversaries. Wireless signals can be scrambled or disrupted. Neutrinos, however, travel freely through planets, through stars, through any physical medium as if barriers simply do not exist. Their interaction with matter is so infinitesimally weak that the Earth itself is, for all practical purposes, transparent to them. If an advanced civilization sought to communicate or operate in a manner that could not be easily detected or intercepted, neutrinos would represent the ideal medium. They would traverse the Earth without obstruction, without blockage, and remain undetectable by conventional observational methods. They would be invisible to our standard equipment. Their detection would necessitate specialized instruments, precisely like those represented by IceCube. The existence of IceCube was not a deliberate search for such signals, but rather an endeavor to investigate natural cosmic phenomena. We constructed this observatory to comprehend the high-energy universe, and in doing so we inadvertently created the perfect instrument to detect exactly the kind of communication that an advanced civilization might employ. If 3i Atlas is an artificial probe, if it carries advanced technology, if it possesses methods of communication or operation that have yet to be understood, then high-energy neutrino signals would represent precisely the kind of evidence we might expect to detect. Such a probe could potentially communicate across the solar system using this medium. It could operate systems that generate neutrino emissions as a secondary effect of their power generation mechanisms. It could transmit information encoded in patterns that our detectors, if sufficiently advanced, could potentially decode. The perceived connections between comets, satellites, and Antarctic observatories might appear as the product of an overly active imagination, the kind of wild speculation that responsible scientists typically dismiss. However, they represent instances of the same underlying phenomenon, anomalies manifesting in unexpected locations, patterns emerging within data that should inherently be random, signals appearing in domains where conventional scientific understanding dictates they should not exist. And all of this is consistently met with institutional silence. All of it is explained away through increasingly elaborate naturalistic models, compelling us to accept an ever-increasing number of improbable coincidences. All of it demands rigorous investigation rather than facile dismissal. The evidence is present, the data persists. The phenomenon we're observing spans a vast array of cosmic scales, from the ephemeral nature of comets to the fundamental principles of quantum mechanics, encompassing everything from our sun to the very heart of our planet. We've reached a critical juncture where we must consolidate these disparate observations, weave together the various threads of evidence, and acknowledge the overarching design that connects celestial bodies like comets and stars, artificial satellites, and indeed, the very essence of the cosmos. This moment of culmination is upon us. Part 15. The Ultimate Convergence. The foundational elements of this entire narrative can be distilled with stark clarity. Three entities observed in formation, three solar flares ignited in a meticulously timed sequence, an extreme negative polarization inconsistent with typical cometary behavior, chemical signatures that suggest sophisticated atmospheric engineering processes, a physical form indicative of geometric structure concealed beneath a cometary guise, a pervasive official silence from every echelon of scientific and governmental bodies, independent observations from numerous sources corroborating the identical phenomena, anomalies within green comets that warrant investigation but remain unexamined, solar activity demonstrably linked to the passage of these objects in ways that defy statistical probability, multiple other comets arriving concurrently, exhibiting peculiar characteristics. And interwoven with all of this, the identification of dark celestial bodies powered by unconventional energy sources, the inexplicable failures within artificial intelligence systems revealing profound underlying complexity, puzzling quantum events occurring in nearby space, and upward-moving neutrino signatures emanating from beneath the Earth's surface that deviate from established scientific models. When you meticulously assemble all these pieces, when you resist the urge to dismiss any single detail, when you strive for synthesis rather than siloed thinking, a pattern emerges that is exceptionally difficult to disregard. We are not confronting isolated incidents. We are observing a deliberate signal. This synthesis suggests a multifaceted event unfolding across various scales. At the cometary level, the appearance of 3 Atlas and its accompanying objects signifies either an unprecedented confluence of coincidences in the history of our solar system or a meticulously planned occurrence. At the stellar level, the discovery of dark stars implies the universe harbors celestial bodies with concealed mechanisms and extraordinary endurance. At the artificial intelligence level, the revelation of hidden vulnerabilities and critical failure points serves as a stark reminder that complexity inherently harbors unforeseen surprises. At the satellite level, quantum anomalies suggest interference with our most sensitive detection instruments. At Earth's level, the Antarctic signal implies a transmission originating from or near our planet, the nature of which we are only beginning to comprehend. These are not unconnected occurrences. They are bound by a singular commonality. This commonality is anomaly. This commonality is hidden complexity. This commonality is the universe revealing that it encompasses far more than our current models have accounted for. And this commonality is leading us toward a specific destination. It points to conclusions that mainstream scientific dogma has been conditioned to reject, posing a fundamental challenge to our established frameworks. The deep-seated discomfort underlying this entire analysis stems from a core principle. Conventional science operates on a foundation of parsimony. We favor explanations that necessitate fewer assumptions. We prioritize natural phenomena over artificial ones. We lean towards explanations that do not presuppose intelligence or intent. This principle, often referred to as Occam's razor, has served us remarkably well, safeguarding us from succumbing to unsubstantiated conjecture and compelling us to exhaust all natural explanations before resorting to artificial ones. However, like any instrument, Occam's razor can be misapplied. It can be wielded as a tool to dismiss genuine anomalies or serve as a convenient justification for sidestepping difficult questions when faced with data that consistently contradicts our prevailing models. When it is employed to rationalize the disregard of patterns and anomalies, when it is weaponized to preserve existing paradigms instead of exploring new possibilities, Occam's razor devolves into epistemological authoritarianism, transforming from a tool for discovery into an instrument for suppressing truth. The pattern we have traced throughout this account suggests that an entity approaching our solar system has instigated multiple anomalies across diverse domains. The most parsimonious explanation, the one requiring the fewest assumptions, might actually be the presence of something artificial. This is not an assertion of alien certainty, but rather a consequence of the alternative. That every single anomaly we have documented is purely coincidental, every observed pattern is spurious, and every correlation is random. The probability of such a confluence of coincidences is considerably lower than the likelihood that a deliberate and tangible event is occurring. This represents a profound inversion of conventional thought. Typically, an artificial origin is considered an extraordinary claim, demanding exceptional proof. However, when a natural origin necessitates the acceptance of an implausible string of coincidences, when natural explanations demand that we stretch our existing models to their breaking point, and when the evidence pointing toward an artificial origin is demonstrably more parsimonious than the evidence for a natural one, the traditional hierarchy is inverted. The extraordinary claim transforms into the natural explanation, and the comfortable assumption becomes the extraordinary hypothesis requiring defense. What we should observe in the coming months and years will determine whether this analysis proves prescient or merely speculative. The primary and most crucial indicator lies in the behavior of 3 Atlas as it approaches perihelion, its closest point to the Sun. If the object is artificial and its companion entities are deliberate, we should anticipate an amplification of the patterns we have already documented. We should expect the solar flares to become more intense, more frequent, and more precisely synchronized with the passage of the objects. We should anticipate the chemical and polarization anomalies to become more pronounced as the object is subjected to heat and stress from its proximity to the Sun. We should expect the morphology to become more discernible if the object's protective shielding begins to degrade. Conversely, if 3 Atlas behaves precisely like any other comet when heated, if the solar eruptions cease or become erratic, and if the anomalies diminish, then we will have gained valuable insight. We will have learned that our anomaly-based reasoning was flawed, and that natural processes were indeed sufficient to explain the observed phenomena. Both potential outcomes hold significance and offer genuine understanding about the universe. The second indicator pertains to the behavior of data. The James Webb Space Telescope, humanity's most powerful observational instrument, will have opportunities to examine 3 Atlas in unprecedented detail. The JWST's capability to observe in infrared wavelengths can reveal clearer morphology, make heat signatures visible, and potentially detect internal structure. If JWST data is collected but subsequently withheld from public dissemination, if it is classified or compartmentalized, or if scientists are prevented from publishing detailed analyses, then we will know that something is being concealed. However, if JWST data is promptly released and thoroughly scrutinized by the broader scientific community, it will indicate that the institutional mechanisms for suppression are not actively engaged. The dichotomy between transparency and secrecy, between scientific openness and institutional control, will become evident in the flow of data. This is directly connected to the third indicator, the release of raw observational data. Scientists rely on FITS files, raw data files that capture every photon, every measurement, every data point acquired by telescopes and satellites. These raw files form the bedrock of all analysis, but their immediate public release is not always standard practice. They are often contained within research groups, occasionally classified or held back pending the publication of official findings. If the raw FITS files from SOHO observations of 3 Atlas are made accessible to the global scientific community, allowing amateur astronomers and independent researchers the same access as government agencies and space programs, then genuine investigation can commence. If these raw files remain restricted, with access limited to authorized researchers operating within institutional parameters, then we can be assured that information is being managed. The pattern of data release or withholding will provide significant insight into whether authentic inquiry is being pursued or if information control is the paramount concern. The fourth indicator involves actual intervention. NASA and ESA have been discussing proposals for asteroid intercept missions aimed at rendezvous with near-Earth objects for study and potential deflection if threats are identified. The Juno mission proposal, in particular, envisions deploying a spacecraft to approach an object and gather detailed, real-time data, streaming observations continuously back to Earth. If such a mission is approved and executed for 3 Atlas or its companion objects, it would signify that the scientific community has assessed the object as warranting direct investigation. This would represent a substantial departure from the current posture of official reticence. It would necessitate budgetary allocations, prioritization, and a willingness to risk spacecraft on such an encounter. If such a mission is proposed but never funded, indefinitely postponed or rejected, despite its technical feasibility, then we can infer that institutional decisions are being guided by factors beyond scientific merit. The decision to investigate or not to investigate, made at the highest levels, will convey more truth about the situation than any press release or official statement. The final and most profound indicator is the matter of public petitions and official disclosure. The Freedom of Information Act in the United States and similar provisions in other democracies exist to ensure that government information is made public unless compelling national security interests apply. If citizen groups submit FOIA requests for classified observations and government documentation pertaining to 3 Atlas, if courts mandate the release of information, and if data and analyses conducted by military and intelligence agencies are compelled into the public domain, then truth will have an opportunity to surface. Conversely, if such requests are denied, if courts uphold classification, or if government agencies successfully maintain secrecy indefinitely, then we can conclude that the system of institutional control remains intact. The resolution of these legal contests, conducted within the normal processes of democratic governance, will determine whether hidden knowledge is revealed or remains buried under layers of classification and compartmentalization. The mind-bending scenario, the one that captures the attention of researchers like Lowe and fuels serious investigation despite institutional resistance, is this. What if 3 Atlas is precisely what Tiago initially reported and what subsequent analyses have suggested? What if it is a reconnaissance probe deliberately entering our solar system, intentionally approaching our star, and deliberately dispatching companion objects to trigger solar activity and gauge our reaction? What if the 3 entities are proof-of-concept satellites, demonstrating capability and establishing a presence? What if the entire event is an act of contact, subtle and cautious, yet undeniable once one knows how to perceive it? What if everything we have analyzed points towards an intelligence from elsewhere in the galaxy, arriving at Earth specifically at this time, in the year 2025, and we are witnessing the inaugural phase of humanity's first contact with non-human intelligence? The ramifications would be truly civilization-altering. Every assumption about our place in the universe would require re-evaluation. Every religion, every philosophy, every political system would face disruption as the undeniable reality of other minds, other civilizations, and other possibilities became evident. No government desires such disruption. No institution welcomes such transformation. This is precisely why silence is maintained, why data is compartmentalized, and why anomalies are explained away. The alternative, the acknowledgement of this presence, is too destabilizing to embrace willingly. Yet, perhaps because of this very pressure, the question demands to be asked: are we witnessing the initial stages of a cosmic contact event, humanity's first genuine encounter with intelligence from beyond our world? Or are we being systematically misled by artifacts and biases, by pattern recognition gone awry, by confirmation bias that finds significance in noise and perceives intent where only randomness exists? The answer is profoundly important. The answer will shape our self-understanding and our position within the cosmos. The answer will determine the trajectory of humanity's future. And at this moment, the answer remains genuinely uncertain. The evidence points in a particular direction. Institutional silence amplifies suspicion, but definitive certainty remains elusive. This is where you, the viewer, must transition into an investigator yourself. This is where skepticism must evolve into curiosity. This is where a comfort with ambiguity must become your foundation. Because the truth, whatever it may be, will emerge not from pronouncements of authority, but from information becoming public, from data being examined openly, and from individuals refusing to accept official silence as a substitute for genuine inquiry. The pattern is present. The anomalies are documented. The questions have been posed. What unfolds next depends on whether a sufficient number of individuals care enough to demand answers. The data exists. The observations have been made, the evidence has been compiled. What remains is for those of us who perceive the pattern to articulate it, to share it, and to refuse to allow it to be buried beneath institutional inertia and comfortable assumptions. 3 Atlas continues its journey towards perihelion. The accompanying entities maintain their positions. Solar activity is intensifying, and somewhere within classified files and compartmentalized data, governments and space agencies possess knowledge they are not disclosing. Whether they will ever voluntarily reveal what they know remains uncertain. Whether the public will ever compel such disclosure through legal avenues and political pressure is yet to be determined. But one thing is unequivocal. Something is happening. Something tangible. Something documented. Something that challenges our comfortable understanding of the universe and our place within it. And the only appropriate response for a thinking species is to confront that something directly, to examine it without flinching, to demand answers, and to refuse to be silenced by institutions that benefit from our ignorance. The truth is out there, and contrary to what a television program once suggested, it is not hidden in the shadows. It is evident in our data. It is recorded in our observations. It awaits our courage to perceive it.